All right, so the first thing we want to look at is how much water any aquifer can store. That is the volume that is allowed to be stored. And as we saw in the previous picture, there can be significant variances between the two available spaces if we're talking about one pore spaces, for example, and if we're talking about fractures, for example, in another. This is an example of how we can measure how much room is available for water in a given material. And this is called the porosity of any material. So the porosity is the percentage of void spaces, just open air spaces, in a rock or sediment. And it has various characteristics that result in higher or lower porosity. Specifically, grain size. If you have a large grain size, then you typically will have a higher porosity. If you have a lower grain size, then you will typically have a lower porosity because all those smaller grains are filling in the spaces rather than larger grains being in contact with each other on edges. So in this example, what they've done is filled a beaker with 1,000 milliliters of sediment and then poured in 500 milliliters of water. And the point is to show that there's lots of airspace, 500 milliliters in fact, in between the grains that allow for water to be stored. The same thing works with a aquifer. If there's sandstone in the ground and it has half of its volume is air, then that amount of material can be stored, water can be stored in. And that's porosity. Now, porosity is a good thing because we want to have a lot of water or oil or whatever it is we're after, but we also need to be able to get that out of the ground. So what characteristic do we need to have good to be able to transfer that material well?